Next piece in line is the connecting rod and the cap, all coming out of one casting. Now I've really been looking forward to doing this piece. This ought to be a lot of fun to do. There's some technical details on it. 4 surfaces, 5, 6 surfaces to be finished, 2 bores, and this is what it looks like before you start. Got a little bit of parting line ugly on there, but for the most part, not too bad. It's very well lined up. This has to be removed off the back and cleaned up, and somewhere along the line you need to determine where you're going to start this piece. So since we have a fixed size here and something that opens up in the back, rod and cap, you have to figure out that we're going to start from right here. So I will zero my initial setup on this bore and move back to my 3-inch 375 center, because that is the center. Then I'm going to have to determine, it gives you a 1/8 max material slot for material removal. Once I have my 3/8 pin in the collet, in the chuck, in the mill, whatever, I'm going to just shift it and see where aesthetically it looks to seat on the back side. If it gives you an 1/8 max and you use a 30-second slitting saw to cut that apart, well, the back half of the cap is going to be a lot more meat on it than the front half. And you'll have to take this all into consideration when doing all the hole features. Ideally, per the notes, it says to do all the holes before you slice it apart. Let's see if that holds true. Also, you want it to be centered. So whatever these dimensions are right now, you want to make sure that equal amounts of material come off and everything remains centered so that it functions as it should when it's running. First step, take a file to it, clean it up, clean the backside off. Then I'll mic this, figure out how much material's coming off. And I guarantee there's going to be a fixture plate for this one. This isn't something you're going to do in a vise. This is going to be strapped down to another piece of material. Most likely with a pin in it to keep it from jumping around. Let's do it. After a couple minutes with a file and some sandpaper, your part should look something like this. I have checked this out mechanically, measured it, and the end here is just about the same thickness as the existing casting. So that's a good place to start. You could shim this thing up, clamp it down. Clamps will be in the way. So I'm going to use this surface here as my primary banking surface. I'm going to sit it on a set of risers, shims, and I'm going to toe clamp it, and I'm going to mill the surfaces off, and that will give me access to everything that I need. Now this little guy right here, this gate that they've so conveniently left on there, is going to come in real handy. Once I pop a hole in this end for the connecting rod pin, I will change over to an end mill and shift all the way down to this end, and I'm going to finish this off straight. Although it's called to be, or shown to be, removed, I'm going to use it as a banking surface. Once I know exactly how far I am from here to here, I can now use this surface to do my drilling and my splitting and everything after that. So this will be a reference surface for when I flip this part to the vertical format for drilling the screw holes. That will come in very handy. Extremely handy. Alright, let's strap it down to a little tooling plate and dust some of these surfaces off. I will flip it, clamp it again, dust it off, orient it, drill it, and get after it. Let's do it. This is the setup that I've decided I'm going to use. We have aluminum on either side of the rod, so hopefully I won't dent the rod this time. If you watch some of the other parts, you know I dented the crosshead slide with a piece of copper. I was surprised that happened. Now in order to line this up, first thing I'm going to do, or first thing I did, was put a 500 gauge pin in the collet, and I ran it down until it was visually in line with the round end of the part. Now that doesn't mean that the part is straight. That just means that this hole is lined up down here on the end. Visually is fine for this, so long as you're confident that your eyes are good enough to line it up visually, have at it. So I'm going with the OD as the representation and not the small recess in the part, because it's the OD that's going to remain when it's done, right? So that's the way I'm going to approach this. Line it up from the line it up from the OD because the ID recess is going to be gone. Now in order to straighten it out or line it up, my air hose is falling off my machine here. Traverse the pin down to the other end of the part. And by moving the y-axis back and forth, you can check the gap from the pin to the outside of the part on both sides. Check the back, look at the number on your digital. Check the front, check the number on your digital. Do not move the table to line this up. It is important that you move the part. Once you move the part to get it centered about the pin so that the pin touches in the front on one number, touches on the back in the exact same number. Now you know that this is straight. Now you got to go back to the front and make sure it's still visually lined up at the front. As soon as you're happy with the way everything is, lock it down. This is the way I'm going to approach it. You could use an indicator, you could squeeze this in a vise if you wanted to and just not worry about the other end. But like they say, 10 people are going to do it 10 different ways. This setup allows me to surface this face right here, put this hole in, and maybe depending on how I feel about the rigidity of this setup, I might pop the holes in here at the same time. I will also, I'm going handheld, get your Dramamine now. I will also face off that casting gate right here. I'm not going to take it completely away, but I'm going to take it down to a known number from the center of that hole. I will use this as a tooling surface. Take light cuts if you're going to do this. I have very light pressure on here, so I am not going to get overly aggressive milling these faces off. Milling the face and pop that 1/4 inch hole in the front, that is next. First operation is going to be to plunge an undersized hole in 3 locations, one at the very tip and 2 in the back, one for the rod itself and the other one for the cap. Those 2 in the back are going to be 1/8 of an inch apart. Calculated wise, as far as the material that is there, 1/8 of an inch is the max recommended on the print and should work out quite nice. This is a 7/32 4-flute carbide end mill. I know this material is grabby and reams nasty, so I'm not going to ream it. I'm going to plunge a 250 end mill through it, and if I have to open it up, I will bore it. So that's the first operation. 3 holes. Let's do it. Hope it doesn't fly off onto the floor. I am staying undersized on the first cutter because if this is not on center to my visual liking, I will have enough material to do an off-center shift and still clean up. In a setup like this, be very careful with the large journal end. It is considerably more mass, and I would think it could flex a little bit. I'm being very delicate with this. I like the alignment of the 125 centers, and everything looks to be, I'm happy with it. For a visual alignment, it's acceptable. Don't forget, we're going to have to remove material from these faces to make this work. I'm going to size up to the 250 cutter for this hole only. you're going to make any shift in where your hole is located, now would be the time to do it. This is an on-size 250 end mill, and after this passes through, there's not too many options you have to shift. I like it where it is, I'm going for it. A quick check off camera told me without a doubt that the 250 dowel pin that came with the kit will not fit in a 250 plunged hole. Of course, the one time you want an end mill to cut oversize and it doesn't. So that's about a 248.5 diameter hole right there. I will come back and bore that just because I'm not going to pass a reamer through this material because it's crap. I'm going to take the 5/16 cutter down the end. I'm going to plunge 2 places on the end. Then the 3/8 end mill will plunge as well. When I have the boring head in, I will make sure all the holes are on size. Most likely going to put this 2-flute cutter back in there and surface off the 2 sides that I can access from this setup. Then I'll switch over and shim it up, clamp it down, and just finish it off to thickness. Let's do it. First hole goes in at 3.375, 3 3/8. This is an undersized cutter. Actually, it's a 5/16 cutter. It's full size, it's just not correct size. Gentle pressure. You do not want this to flex. If it flex, the chances of it grabbing would increase, and that would be a bad thing. I do not want to blow this part. Well, it's something important to note here. If you're afraid that your cutter is going to grab your part, lock the cutter in place with the spindle lock and come up with the table. The chances of the spindle, quill, cutter diving down into the part is almost completely eliminated at that point. If you don't have that capability, then walk your quill stop down slowly and just keep hitting the stop with the cutter and let it bottom out each time. That's what I'm going to do now. Be extra careful if you do this with half a hole. You have increased the chances of it grabbing considerably, not only because it's a 2-flute and it's grippy material, but the interrupted hole will give you a lack of continuous surface contact. So be real careful. This would probably be a good time to come up with the table. .3/8 2-flute cutter currently in place. I'm going to double check the torque on the clamps, make sure nothing is moving, and I'm going to go down through that like there's a sleeping baby alongside this machine. This is not something that I'm incredibly comfortable with, but I'm going to do it anyway because its setup is just ideal. The access is ideal, not the setup. Here we go. Alright, little production note for you guys. If you are comfortable doing the plunge operation like you just saw me do, and the hole size doesn't come out exactly like you want it to, it is your model. You can size the journal on your crank to fit this rod. If you don't have capability to make a precision hole here, then by all means make the journal on the crank a little smaller. I would say that would be perfectly acceptable, but we're not going to final size those until this thing is split and screwed together. We're going to come back and do it again. Right now I'm just going to take off the amounts that I've calculated to take off on these faces to bring it down to the first step size. And then I'll cut that back notch and tell you what that works out to be. Calculated on the large side, we're looking for 0.325, just under 1 millimeter coming off of this face right here. Let's do that. Just about the exact same amount comes off the front. We're going to go 0.30 deep on the front face as well to blend almost to the rod thickness. There is no dimension on the print for this. I am looking for a clean surface where that gate is right now. Hopefully an even number, something that I can work with comfortably when I stand this part upright. So we're going for a clean surface on that, and if you're not up to speed on exactly what's happening here, this will be a lot clearer as this part develops. But just clean this off if your part has this. Don't clean it off, just clean it up. The difference. Alright, that is all I'm looking for. My digital readout now says 4 inches 0.30. This is a 375 cutter with everything originating from the 250 hole in the front of the rod. So I can calculate how far this is to the center of the pivot point, and this will also give me a step for each drilling operation on both sides. And it is time to take this part out, clean it up, flip it over. Actually, I'm going to bore it first, but that's going to show up in a second. And let the boring operation begin. 375 in the front, 250 in the back. If either of these holes needs to be a slight oversize, both of them can actually be oversized because the front one is going to clamp and the back one is going to clear. So I would say at least the number on the print. I'm going to use a gauge pin to make this fit, and I'm also going to make sure that the dowel pin fits in there. But after we split it, put the clamp screw on it, nothing is going to move in this end. This is going to hold a stationary pin. There will be no pivoting going on inside of this. This is a clamp. Beauty. Okay, shift over to the back, do the 375. I'm going to move on to the 375 offset holes on the large end of this particular rod, and I am going to bore them directly to 375, both of them. I have confidence I can split this piece and put it back together and have a round 375 hole, and if it's not, I can clean it up at that point. But for the most part, the easiest solution would be to do an undersized hole, mate the caps, and then ream it. I'm going to bore it. That's just my approach. beauty. I like it. All right. 125 offset, leave the boring head where it is. Do it again. Alright. That is all you can do from this side. Let's take it out, flip it over. In order to assure that the second side of the large rod end is parallel to the first side, I've got it strapped directly to my tooling plate. I will take a very superficial cut on here, 10 thousandths give or take, and use a depth mic to determine the thickness of this end. If you don't have a depth mic or can't fit a depth mic in between your clamps, zero your tool on the registration surface and just move it up or drop the table down from there. Looking for 435. And that's what I'm doing right here. Or 58 and a half. Three more. I like it. Let's flip it over. The small end can be done exactly the same way as the large end, but for sake of being sure, in case the downside is subsurface to the neck of the part, I'm going to take this off mid-cut and mic it and put it back on. Do it. Okay, quick look interim. There's the small inclusion that showed up while it was coming off. That is almost on the split line. That would be ideal if that was on the split line, but it's not. I don't think that's going to hurt it at all. You can see that the neck, the head is almost as thin as the rod itself. It is intended to fit here. And you can see there's a couple thousandths of an inch clearance in there. The big end, I've deburred the outside, hit it, Scotch-Brite wheel, and I am going to split that right on the center of the lower hole and then make this one fit. Next step is to put the screws in, with the screw features in. And now this is where this flat comes in handy. I know it's 3 inches 375 to the center of this hole right here. That is also the split line. By knowing what it is to here, I know what it is from here to the split line. The split line is where the clearance hole must end. It's okay to go a little beyond. It doesn't have to be absolutely spot on critical. But the clearance hole for the cap screws needs to go at least to the center of this bore right here. So by knowing where this is, you can touch off, you can drill down accordingly and hit all your numbers. That is a good thing to do. I'm glad that they left that. It's going to make life easier. Quickie little, let's check it out. Let's check it out. Love it. See, there's about 5 thousandths worth of clearance in there. I'm sure that's enough. The pin will be pinched on the rod. This is going to be the pinch mechanism right there. I believe that is probably what I'm going to do next. That just looks like too much fun not to do it. Nothing critical here. As long as it squeezes that pin, you're good to go. I'm going to line it up visually 45 off of this face right here. So we're going to set it up in the vise this way, drill down, drill and tap it, and then we're going to stand it up, split it right across the center of the pin. Let's do it. For the next series of features, it is really helpful to know the distance from the inside of your 1/4 inch hole to the outside of your casting. They're calling it out as 3/32, and that is a supposed center line of mass right here. But if your hole is shifted off center, then shift your other features accordingly. Try to stay in the middle of this gap right here. Mine turned out to be 172, so I'm going to go with 86 as an offset as opposed to the 93 that they're asking for here. It's close enough, it's fractional. This is 15 thousandths implied. So I'm going to touch off the back of the vise with an edge finder, move in half the thickness of the part to find the center line. Then I'm going to bump the edge with the edge finder and shift over to my 86. Let's do it. Let's take a look at the setup. Nothing fancy. Going handheld. Here we go. The top of the rod is proud of the jaw, so that I can put the spot face on there that they've called out. It's just a bunch of blocks all stacked up, pressing the rod directly against the back jaw. And we're back. The 45 degree is established by pushing a small square up against this feature right here. This is what you want to have parallel to all the holes going through it. So rely on that. The rest is cake. 0 off the back, move out to split the difference. 0 off of here, move in to find your center. Spot, face, clearance drill, drill and tap. Then we'll shift it out and split it.